we discussed hypothesis testing, how we need to conduct hypothesis testing, those stuff. But we didn't discuss uh, how do we calculate those test statistics and how we make the decision. Okay, so in this section, 8.2 and 8.3, we are going to discuss how we deal with or how we perform this kind of hypothesis testing. Okay, uh, uh, this section in this section there are three cases. Okay, I have divided this section into three cases: case 1, 2, 3, according to their behaviors. Like if we have a large enough sample but we don't know about the population, then how we deal with the test statistic, something like that. Okay, so there are especially three cases, and also I have added more examples to this section. Okay, so first thing, we in general we do our hypothesis test for mean, population mean. We assume that we don't know population mean, and we conduct our hypothesis testing. Okay, you know that sample mean is an unbiased estimator for population mean. Okay, x bar is unbiased for mu. Okay, so that's the theory behind it. Anyway, I think you may remember these steps I did in chapter 8.1. These are the steps for hypothesis test. First, let me recall these steps. First, you have to define what is your H naught and HA, your null hypothesis and alternative hypothesis. Then pick the correct test statistic. Okay, find the rejection region or p-value, because I told you we use two approaches to perform this kind of hypothesis test. First one is, I mean, not first one. One approach is critical value approach, so that we need this rejection region. The other approach is p-value, so that we need p-values. These are probability values. Okay. So this rejection region mean a value on this axis. Let's say we have this kind of distribution. So value on this axis, this real line, we use in critical approach, critical value approach. Okay, we use area, I mean the area under this curve, or probability value in p-value approach. Okay, okay, that's the difference between those two. Okay, then finally, it doesn't matter which method do you use, either critical value approach or p-value approach, you should be able to get the same answer. Okay, so according to the existing information, you can use either critical value approach or a p-value approach. Okay, finally, I mean, you have to find the correct conclusion about H naught. Okay, about H naught, not HA, about H naught. Finally, wrap up everything and give you a conclusion. Okay. Okay, so these are the major hypothesis tests we are going to deal with. Left tail, right tail, or we call lower tail, upper tail. These are one tail test, and the other one is two tail test. Okay, two tail test because of this inequality. This is of not equal. Okay. Okay. This is how we reject or do not reject. This is the criterion for reject or do not reject. Okay, whatever. Okay, our rejection region is, let's say, 0.05, this area. So whatever in this region we reject, whatever outside this region we do not reject. Okay, that's the criteria. So as I mentioned, this value we need for p-value approach. This value, something like this, we use to critical value approach. Okay, so those are the two things. We will discuss that later. Okay. Okay, what is this? Okay, alpha given, which means your rejection region is given significant level. It is 0.05. So according to that, okay, first one left tail test. Since it is left tail test, your rejection region in this side. If it is a right tail test, your rejection region this side. Okay, this value is the C-score value based on 0.05, alpha 0.05. Okay, once you check the standard normal table, you will see that this is the C-score value based on probability value 0.05. Okay, since uh, standard normal distribution is symmetric, doesn't matter. See, only their sign change. Okay. In this case, what happened? Two-tail test. If you remember, you have to get the alpha over 2, both sides. Remember that? Alpha over 2. So this value is C 0.25. Sorry, 0.025. Okay. So this is the C-score value based on alpha 0.025. Okay. So whatever, for an example, pick this one. Whatever value within this region or here, we reject. Clear? So first case, which is we have normal. We have a normal distributed population with non-variance, but here we don't know about the mean. But we know we have this guy, non-variance, which means sigma. Okay, it is known, and our population is normal distributed. So at that point, it doesn't matter about the sample size. You know that, right? We can assume yes, sample is also normal distributed. Okay, so these slides, which I added last night, those are taken from Math 23, which is Introduction to Statistics. Okay, which I taught last fall. Okay, so okay, let's go through this case one. In this case, case one, which means we have a normal distributed population, variance node. No problem, we can use our C test. Same thing, how we deal with C-score, same here. Okay, same thing. We call here C test. Okay, so check these ones. How we deal with C test? We assume that, if you remember, we assume that our samples or our observations are IID. What is IID? Independent and identically distributed, or identically independent identically independent distributed. Okay, IID. Population is distributed normally. Okay, which means it has a normal mu sigma square. Okay, all xi's. Okay, so mean is mean mu unknown. We don't know about the mean, so we are going to conduct our hypothesis test for mean. Okay, but we know this guy here, standard deviation or variance. Okay, standard deviation or variance, we know. Here we have mentioned unlikely in practice, because in practice we don't know population standard deviation. Okay, but still we can use that. Okay, C test, same here. C test, C equals C statistic. Okay, we call this C statistic, this guy, equals x bar minus mu naught divided by sigma over square root of n. Okay, I think last day I did something wrong. Here should be a square root of n. Okay, why this is mu naught instead of mu? If you remember your null hypothesis, we consider mu equals something, a value, right? Something like this. So this value is my mu naught. Clear? So you have to replace this mu naught by using your null hypothesis value. That's why we take equal there, so that you can simply get that value to calculate this C statistic. Okay. C statistic has a normal distribution has a standard normal distribution when H naught is true. Yes, we always consider H naught is true because we need to calculate this C statistic. So we consider mu here, mu naught. Okay, that's why we consider H naught is true. This, which means we consider this one to calculate C statistic. Okay. We know this guy, or we can calculate this X bar. We know this one from our null hypothesis. We know this one because this is known case, sigma known. We know this one, so you can calculate C. Okay. This gives you a value. Okay, not a probability. This is a value. Okay, rejection region for the critical value approach. Sorry, C test critical value approach. Okay, for the critical value approach, okay, all negative. These are the hypotheses, all negative hypotheses. Rejection region when our critical region, critical value, which critical value mean this value. This value here, what we get from here, we call it critical value. That C value, that C statistic value, we call critical value. Okay. So without any problem, here we have C value. We normally we call this, we need to write this. We write it like C cal because this is a calculated value. Okay. So we denote this like C cal, calculated value. So this value, if this value is greater than or equal, that's fine. Greater than or equal C alpha. What is C alpha? That this value in belongs to this region here. This value is the C alpha. So my calculated value is somewhere here. I'm not talking about the probability. I'm talking about the value. So my C cal is somewhere here. So that no problem. We have to reject our null hypothesis. We reject H naught, our null hypothesis, which means we are talking about all negative hypothesis. Okay, but still I'm not telling you we are going to accept null all negative hypothesis. Okay, but we reject H naught, so we have to consider all negative hypothesis. Okay, check this one. Let me erase this. Check this one. This is what I mean. Since it is this is HA. Okay, I'll write it like this. This is your HA. So this is what? Left tail test, right? This is left tail test. Clear? So what is left tail test? Something like this. Okay. So what is your, now I'm talking about critical value approach. So what is your rejection, this point, critical value? This one, C alpha. Okay. Here they have mentioned negative C alpha because left side normally negative. Okay, it doesn't matter what's the value. This is your C alpha. So whatever here, I mean whatever in this axis from its beginning to this point, we reject. So once your Z value or C cal value somewhere here, C cal mean value from here, this one. Okay, so whatever here we reject. Okay, it's obvious, right? So that's they have mentioned here. Okay, so here this one again, it is your all negative hypothesis, two-tail case. This is two-tail, which means like this. I draw this area, but I'm not dealing with this area. I'm dealing with this value. These are the rejection values. Whatever this side we reject, whatever this side we reject. If our C cal within this area we reject. That's what they have mentioned here. See these two based on left side and right side. But only difference is here alpha over 2, not alpha, because we cut alpha to 2 halves and deal with like this. This is critical value approach, how we take our decisions based on its rejection region. P-value approach, Okay, I'll show the p-value approach, the same picture here. Whatever within this area, whatever within this area we reject. Okay, clear? Oh, you will see in examples. It's p-value, which means probability value. Okay, I'll show you later how we deal with probability value. Okay, so that if we calculate our probability value, this p-value mean what value we calculated. Okay, clear? This significant level mean alpha. So our calculated probability value, if that value less than our alpha, we reject. It's clear, right? Which means it's somewhere here, like that. Okay. This for this case, if you are using p-value approach, there is a little bit different than the other two. Okay, we will see that. Okay, these are the important C alpha values I have mentioned here, but here again you can find this from the standard normal table without any problem. Okay, here I have mentioned some C values we are using very frequently. Okay, see alpha equals 10%, 5%. Okay, something like that. Clear? So according to those values, once you check your standard normal table, you will see these are the values. Okay. Again, you can find these values from the standard normal table. Okay, this is the p-value criteria, how we deal with the p-value. If a C0 value from the C-score table, okay. So according to this C value, do you remember how we calculate x bar minus mu naught divided by sigma over square root of n? This is the C value. Okay, this is the C value. So you have to go to the standard normal table and find the corresponding probability value based on this C value. Okay, that value we call P value. Okay, that value we call P value. So we denote that value from simple delta. Okay, which means this area colored in blue color area is delta. Okay, it is your probability area, not the significant level. Significant level is different one, but they have given. This is something what you have calculated. Okay, that's why we use different notations. Okay, so delta mean what you calculated using your calculated C value. Clear? So left tail test doesn't matter, easily you can find that value. Okay, but once you deal with greater than case, which mean right tail test, that delta, that p value, delta is same, p value you can calculate 1 minus delta. This delta mean probability based on CCAL. Okay, you know what is CCAL? CCAL means this one. Let's say CCAL. Clear? This delta. So 1 minus delta. Since this is right tail case, you will see delta value is very larger values like large 0.5 greater than 0.5, so that this p value become smaller value. It depends on the problem again, but clear? Okay, this one two tail case. Again here we denote this one area delta, doesn't matter. So from the C table you find this one. Okay, then your p value you can calculate 2 times that guy. Okay, 2 times that guy. This one, yes. CCal. Once you calculate CCal, I mean same thing here. Probability based on CCal is this one. Okay. Let's say CCal is 0. Okay, go back here. Okay, let's say CCal value is this one. Not this one. This one. Okay. Okay. So based on the sorry, CCal value is this one. Okay. Then once you check your standard normal table, you will figure it out. Okay, that probability value is 0.025. Then what you have to do? You have to multiply that by 2. This is your p value. Okay, clear? That's the example. Okay, if for an example, according to this case, you find out, okay, your delta is 0.025. Okay, then your p value you can calculate using this one, equals 2 times delta. Okay, that's how we deal with two-tail case. This is only for this is only for two-tail case, this one only. Okay, because we consider two regions, left and right, that's why we multiply by 2. Don't forget it. Okay, I have examples for these 3 different cases. We'll go through that. Okay, p-value approach. Check these examples here. Yeah, test statistics C. We need to calculate p-value, and we have to we have to decide whether they are reject, whether H0 is reject or not. Okay. Again, significant level is given. This is alpha, not delta. Okay. Check this one. If C score value, your CCal value is CCal value is 1.32. Go to the table, and also this they have given, this is the right tail test. Okay, right tail test mean something like this. Your alpha is this, equals 0.05, significant level. You need to find your p value is somewhere here or here. I mean, I cannot show it like a point. Let me so okay, if I draw the p value, I don't know about the value, but let's say your p value is something like this. This is your what? Delta. Clear? So you have to compare these areas. Here, see this colored area, which one is the bigger or which one is the smaller. Okay, based on that you decide reject or not reject. Okay. Okay, let's see these values. So go to the C table, find the probability based on this. That value is it is 1.23, sorry, 1.32. It is 1 minus. So this 1.32 value is this. So you have to take 1 minus. Do you remember 1 minus delta? That is this value. Okay, right tail test, 1 minus delta. That's your p value. So your p value is where this one, 0.9. So now you have to check this p value, which is 0.934, and your alpha. Alpha is 0.05. Which one is the bigger one? Your calculated value, which is your p value. So it is like this. Okay, it is like this. So this is your alpha. This is your alpha, and this is your, I'll draw it dash lines. This is your which side? Okay, this side. I'll color it horizontal lines. Okay, this is your delta. See, delta is greater than alpha. Okay, see, it is go beyond the rejection region, right? So at that point, what we do? We do not reject, because if you remember that slide I showed you, whatever here we reject, not just reject, we reject H0. Whatever here we do not reject. This is alpha. This is delta. So delta greater than alpha. Whatever here, reject. Whatever here, do not reject. Okay, so your p-value is in the do not reject area. Clear? It go beyond that rejection region. Okay, because p-value, I mean, it's a value, yes, but since it is an area or probability value, that's why I colored it like this. Or simply you can, okay, if you are confused with this, I can show you something like this. This is your alpha, okay? And let's say your p-value is somewhere here. Your delta is something like this, okay? Clear? Something like this. That's why we do not reject it, okay? Because of this. Remember that which test you are performing, okay? Everything change if you use left tail test, okay? If you use right tail test, so your test something like this. So please try to remember while you are solving your problem, try to remember what which tail you are dealing with, okay? Okay, second one, left tail test. Your value is this one they have given. So easily, if it is left tail, this is your delta. So you can pick this one is your delta. So you can check delta and alpha. So here delta value is 0.2. So definitely your alpha greater than delta. So it is like this. Your alpha, your delta is somewhere here. Oh, sorry, sorry, not this one. It is left tail test. Okay, don't forget about it. It is left tail test. See, it's a left tail test. So your alpha is somewhere here, not the right side, this side, left hand side. So this is your alpha. And your delta, it is somewhere here. This is your delta. So it is inside the rejection region. There is no problem. We reject H0. Okay. Only we are talking about H0 only, not alternative case. Just H0. Reject or do not reject. Let's say okay. Let's check the third one. Third one. Let me go back. C 2.15. Okay. C value, probability of C value here since okay this value is 2.15 is here. Since it is symmetric, you can consider negative 2.15. Why we consider negative? Why we consider less than case? Because CDF gives us less than case, right? Sorry, something from beginning to that point. That's why we consider like this. It doesn't matter. You can, if you need to find this probability for this case, you can find it, but you have to get 1 minus once you consider that. Okay. By considering symmetric property of the standard normal distribution, you can easily find this delta. But this is a two-tail case, so you can find this p-value by multiplying that delta by multiplying 2. Okay, so 2 times this value, this much. Again, check your alpha and your delta, or 2 times delta. Or let's say here we can say p-value. Okay, p-value. So you can see your p-value is 0.3 something, which means less than alpha. So here you don't need to think about this value, this probability belongs to this side or this side. Whatever less than alpha, reject. Because we take care of that by using 2 times by multiplying 2. We take care of that both sides. So you don't have to worry about that. Just focus on the values, p-value and alpha. That's it. Okay. No need to think about whether it is this in this area or this area. No problem with that. Okay, clear? This is the p-value case. Clear? Any questions? Okay, check this example. So your questions normally looks like this kind of questions. So I think this is based on p-value, but I'll show you how to solve this using p-value as well as critical value. Okay. Okay. Serial contain less than. Okay. Do boxes of cereal contain less than this much on average? Okay. So less than this one. So what is the researcher's claim? This is the researcher's claim. Your H naught doesn't matter. You don't need to read the question to write the H naught. It's always mu equals mu naught. Your HA, alternative hypothesis, is mu what? Contain less than this much. Oh, sorry, this mu naught mean 380. Okay, this is less than this much. This is your mu naught. Okay, mu naught equals 380. Okay, clear? This is your here you don't need to write mu naught. You can write 380. Okay, that's fine. Random sample 25. So you know what is n. N is 25. X bar given. See, X bar given. Company has specified, okay, sigma given. So sigma known, and also assume normality, which means they have mentioned that, okay, we can assume our normalities. Population is normal distributed. That's fine. So it is easy. Significant level alpha 0.05. So how do we perform this test? I have solved this in next slide, but here I'll show you how to start with this. First, you have to find the C-cal. Although you use p-value or critical value approach, you have to find the C-cal, I mean C-value. So X bar minus mu naught divided by sigma over square root of n. I'm not going to solve this, but I'll show you, I'll just plug the values, okay? 5, mu naught is 380 divided by sigma, it is 15, divided by square root of n, it is 5. Simplify this one, you will get a value, okay? You will get a value. That value is C-cal, okay? That value is C-cal. Okay, now you have C-cal. Now you can decide which method you have to use. Doesn't matter which one you use, you will get the same answer. Okay, so let's say you use p-value approach. P-value approach. Then you have this alpha. You don't have to do anything with alpha, but you have to convert your C-cal to a probability value. So go to the table and find the corresponding probability value, which means p-value. First, check this one. This is less than case. Okay, less than, which means we are dealing with left tail. Okay, so easily go to the C table, and find p-value, which is I'll denote it delta, okay, because left tail test we denote it delta. Then you can check delta, compare delta and alpha, and give your conclusion whether you reject or not. The other way is, or this is one way, the other way is use your C-cal as it is, convert this alpha to a C value, okay? Find C score for alpha, which means what? We call it C alpha. Do you remember that? C alpha. Okay. So compare, after that, compare Z alpha and your C cal. C cal means this value here. Based on that, you can take your decision. Clear? These are the way how we deal with hypothesis test. Okay, I think next slide we have solved this, so you can check the values. Okay. See, this is null and alternative hypothesis. These are the given values, sigma naught. Yes, we can find our test statistic. Test statistic, or you can use CCAL. That's fine. We call this test statistic to avoid confusion. We use C sub cal. Okay, calculated C value. So this test statistic value is negative 2.5. This is p value approach, I think. Yes. No, sorry. This is critical value approach. So this is critical value approach. Oh, sorry. Critical value approach. Critical value approach. Okay, critical value approach. This one. Why? They have figured it out. What is the critical value for alpha? So alpha is 0.05. This is your Z alpha. It is this one. Value here. This is C alpha. So now you can check these two values. Which one is the greater than, which one is the highest value, or which one is the lowest value. Okay. What about these two values? Negative 2.5 is less than negative 1.64, right? Which means your test statistic value C cal is somewhere here, right? So you know what to do. We reject H naught. Why? Your test statistic value C cal is less than your critical value, C alpha. Okay. Why? Because this is a left tail test. Is that clear? If you can understand one scenario, then it is same for all other scenarios. Okay. I mean, it's very similar. So most of the time you students get this up to this point, but they do not do, they messed up with the rejection, whether H naught is reject or not, that point. Okay. But try to understand very clearly. This is easy. Once you calculated these values, take your decision. Okay. Finally, this is this one doesn't matter. You don't have to write this. This is for you to understand. This is what you need to write at the end. I mean, you don't have to write the conclusion. This is what. Just write this at the end. You have to write what you your conclusion. Your conclusion. Okay. So we reject H naught. Yes, this is your decision. We reject H naught at. Yes, you have to write what is the significant level. Clear? Because your answer based on your significant level. So we reject H naught at this significant level, which means, okay, we have which says that we have enough evidence to say that we reject, enough evidence to say that what they have mentioned, which means HA. We have enough evidence to say that this one. Okay. Here, since we reject, we deal with HA. But here we have not mentioned that we accept HA. Okay. We say that we have enough evidence to say that this is your HA. This bold color letter, this sentence means your HA, what you have taken here. See, cereal contain less than 380 grams on average. Okay, this is actually what they have mentioned in the question. Clear? So this is a complete answer for this kind of question. So in your final exam, you will be having this kind of question, plus some parts for critical, not critical, confidence interval. So these things can combine within one question. Test statistic, I mean, unbiased estimators, the this one hypothesis test, and confidence interval. Those three things can combine inside the one question with 3-4 parts, subparts. Okay. Okay, it's 45. So okay, I'll show the p-value and it's done. Okay. So if you need to use p-value approach, doesn't matter. This is same. This is same. Your hypothesis, it doesn't matter. These values are same. Again, no problem. As I mentioned, you have to calculate your C-cal. Then you have to find the probability for this value. Okay. So this probability p-value, which means delta, is this one. Easily you can see that this delta less than alpha. Okay, alpha is 0.05. This value is 0.0062. See, less than, which means somewhere here. Reject X naught. Then you have to write the same thing. So as you can see, it doesn't matter which approach you use, either p-value approach or critical value approach, you will get the same answer. Okay, but most of the time we use critical value approach because it is easy. You don't have to go to the table and find those values, because we know, I told you, we know what is C alpha for alpha equals 0.05, those values, right? So easily we can use that. That's why we use critical value approach. Okay, but there is no rule like you have to use this, you have to use this. Okay, otherwise they have mentioned in the, I mean, if not, unless they have mentioned in the question, you have to use specifically p-value approach, then you have to use it. Otherwise, no problem.